when Copernicus put forward his idea of a new model for the solar system that's centered on the sun, he was sort of competing against the system that Ptolemy had put out over 1,000 years earlier, this idea of these circles on circles. I just want to take a look at these two possibilities to see how their predictions weren't all that different from one another, and how what people could just see in the sky with their eyes, it wouldn't look any different whether the Earth was at the center or the Sun was at the center. It's kind of hard to believe, but remember, here's Ptolemy's system. We have the circles on circles, the idea being that the Earth is pretty much at the center, and that Mars, for example, is riding on an orbit that's riding on another orbit around the Sun, and then we get this little loop that happens of retrograde motion. And in fact, it actually predicts the retrograde motion and explains it relatively well. In fact, very good. Good enough for about 1,500 years worth of astronomy. Now, Copernicus makes the different claim, right? He says if the sun is at the center, this is just a simpler way of explaining the same motion. So let's take a look at what that would look like, right? In a Copernican system, a heliocentric system where the sun's at the center, we'd see that all the planets are orbiting. This is the familiar view. All planets are orbiting in circles around the sun. And Copernicus, one thing that was incorrect, according to our modern understanding, is that Copernicus had all the planets orbiting in perfect circles. We know today that planets don't orbit in perfect circles, but nonetheless, it was about the same as Ptolemy's system with using perfect circles. And we can see, for example, the Earth is orbiting right here, coming around, there it goes, and here's Mars. And now what may not be clear is how this system, this way of looking at our solar system, also explains retrograde motion. It might be like, well, look, Mars is just moving forward at a constant speed. How is it possible that it turns around and moves backward in our sky? The key is when Earth passes Mars, just like it did right there. If you think about riding on the Earth as it's orbiting around, how would that change our perspective on the planets? And when it comes and it passes Mars, just like when you pass a car on the highway, that car appears like it's moving backwards. Like if you're just like an idiot driving on the highway, you didn't know you were moving, and you're looking at the other car, it looks like it's going backwards, right? And well, here on Earth, that's what the planets look like they're doing. And here I can illustrate it another way. So here's the sun, here's the Earth, here's Mars, right? And the Earth is orbiting. It orbits a little faster than Mars does, so it laps Mars every once in a while. And now here we can see the stars in the sky that we're looking at from Earth, and we see Mars is appearing in our sky, just like we saw before. Mars is among the stars. And now watch what happens as Earth laps Mars. Okay, Mars is initially going forward. It slows down, stops, turns around, starts going backwards as we're lapping Mars. It looks like it's going backwards relative to the stars. And then once we kind of finish lapping it, it kind of turns back around and keeps going forward again relative to the stars. Well, this is exactly the retrograde motion that we saw before in Stellarium. So the point here is that this simpler model, I don't need circles on circles, everything just orbits the sun, I can still explain retrograde motion. And in fact, many of the predictions that were made using the Ptolemy system were the exact same using the Copernicus system. There was no clear immediate advantage to switching to the Copernicus system, the heliocentric system, because it didn't change your predictions in the sky. We'll see, though, that there are a few things which are different. We'll look at that in just a minute. I just want to illustrate this one more way, how these two systems really were very similar in just a matter of perspective. So this is the sort of heliocentric view. We have one planet orbiting and another planet orbiting. It looks familiar. And I just want to illustrate that if we just change sort of our focus, like let's just say our camera that we're filming this with instead was focused on this moving red dot. So let's just say that's the Earth and this is like a geocentric. We're going to switch to a geocentric view. All the motion will be the exact same. I'm just going to start my camera moving, focused on the Earth. Now watch this. Boom. So now you can kind of imagine that my camera's moving, following this red dot around. But now if you kind of shift your eyes and say, let's just imagine that the red dot is actually sitting still. Now I see this other planet, and it's moving on a little circle, and that's a circle on a bigger circle that's orbiting. So you see, like, just by changing the focus of our attention or our eye, where we think the center is, the motion actually doesn't necessarily change. Okay, that's not to say that these two systems are identical. There are a few predictions of places where the Copernican system, a heliocentric system, is different than a geocentric system.